Hey, it's the beginning of a brand new unit. We're going to study regretting moonlight rarity. Yeah, I would certainly regret if I didn't see a rarity in the moonlight like a... No, this can't be what we're going to study. Regretting moonlight rarity? Let me see. No, it looks like we're going to study right triangle trigonometry. Right triangle trigonometry. Oh my goodness. So much fun. Right triangle trigonometry is what we're going to be taking a look at. So, Unit 8, lesson number 1, we'll be able to use the Pythagorean theorem. All right, first of all, triangles, of course, have 3 sides and 3 vertices. We use capital letters at the vertices. So if we refer to an angle, it's also a capital letter A or B or C or whatever part of the alphabet, but they're capital letters. The sides are going to be a lowercase. Notice that if I'm looking at side A, it's across the triangle from angle A. Well, if I'm at side B, I'm across from angle B, right? And quite often we use C as the right angle, and therefore we use lowercase c as the long side opposite, also known as the hypotenuse. Don't have to, but we usually use A and B for the acute angles and C for the right angle. Notice we got the little square marking at the angle labeled C, so you know that's the 90-degree angle. All right, that means it has a measure of 90 degrees, right? It's a right angle. Longest side, again, is the hypotenuse. We usually use the letter C for hypotenuse because we usually use capital C for the right angle. All right? Hypotenuse is also across from that right angle. And now notice that sometimes I'll talk about the 3 sides of a triangle. But when we get to a right triangle, instead of talking about the 3 sides, we talk about the hypotenuse and the 2 legs. All right? The legs are the shorter sides on that right triangle, right? You get 1 hypotenuse, you get 2 legs. The legs share a vertex at that right angle. So the Pythagorean theorem states, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. In other words, c squared, right, that's the square of the length of the hypotenuse, is equal to a squared plus b squared. Those are the squares of the lengths of the legs, right? So we add them together, right? Sum means add. Okay, so let's actually figure out how this thing works. Let's do some examples. I want the exact value for the missing side of each right triangle. So the first thing I'm also going to write down on my paper, I'm also going to write down a squared plus b squared equals c squared. All right, that's the first thing I'm going to write down. It looks like across from angle A, I see a 6. Across from angle B, I see an 8. So lowercase a is 6, lowercase b is 8. We're looking for C, the hypotenuse in this case. Of course, 6 times 6 is 36. 8 times 8 is 64. I will add those together. Use a calculator if necessary. Take the square root, right? Because I don't want C squared, I just want C. Square root of 100 is 10. Notice that I don't do the plus or minus when taking the square root. Usually when solving an equation, if I did the square root, I would put the plus or minus in front. But we assume with these right triangles that all sides have a positive measurement. And so we're not going to put the plus or minus in front of the square root. Okay, again, first thing I write down, a squared plus b squared equals c squared. And this time it looks like we're looking for a, right? Across from angle A, I don't see that leg labeled with a number. I know leg B is 10. I know the hypotenuse C is 26. So I can plug those numbers in. Now, 26 times 26, my hunch is that not too many of us have that one memorized. Right? 10 times 10, you're like, I got this down. But definitely on 26 times 26, you're going to want to grab a calculator. Now, students sometimes just get going really quick without thinking because they're thinking a squared plus b squared, a squared plus b squared, a squared plus, right? And they all just automatically add. Notice I'm not going to add in this case. If I need to locate the hypotenuse, then I add. But if I'm trying to find a leg, notice we actually subtract, right? To isolate a squared, I need to subtract 100 from each side. Again, they invented calculators for a reason. When we start getting up into the larger numbers, right? When we start hitting triple digits, it's like, add, subtract, grab a calculator. And then certainly for the square root, not too many of us walk around memorizing this one. Right? So I'm going to grab a calculator and go, oh my goodness, it's exactly 24. How lucky can I get? And so the missing side was 24. You're like, oh, come on. Why do we need a third example? I got it at this point. I got it at this point. Let's see why there's a third example. A squared plus b squared is c squared. We know b is 10. We know c is 20. We're trying to find a. Now, also remember, using a calculator for 10 squared, I could also do 10 times 10. Same thing with 20 squared. I could do 20 times 20. So I've got 100 for 10 squared. I got 400 for 20 squared. Again, since I'm looking for a leg, I actually end up subtracting. Right? And so, oh my goodness, a squared is just 300. And of course, I don't want a squared, so I'm going to take the square root of 300. And of course, I'm going to grab a calculator. Very, very interesting. Yeah, not only is the cow holy, the cowbell is holy. Look at that. Do we remember the instructions? A couple slides back. We want the exact value, not a decimal approximation, right? That is not an exact value on my calculator. It's pretty darn accurate to many decimal places, but it's not exact. I want an exact value, not an approximate value. So, time to revisit, my friend, the square numbers. It's kind of funny, there's almost a step backward because we've spent so much of this school year looking at cubes. Now we're looking at squares. And so I got to ask myself, well, if I'm looking at 300, which square number is a factor of 300? Well, obviously 1 would be a factor, but that's not going to help me, right? Because 300 would become 300 times 1. 4 will divide in there, but it's going to create a lot of work for me to reduce further, right? Because I want the greatest square number. So I keep bopping down. 25 was also a factor. Ooh, 100. There we go. 100 is the largest square number I can think of that divides evenly into 300. So I can rewrite square root of 300 as square root of 100 times square root of 3. And of course, square root of 100 is 10. And so there is our exact answer. 10 root 3 is our missing side. All right. Square root of 300, technically that is a exact answer. But cool mathematicians, no, is that redundancy, right? I mean, cool mathematician. If you're a mathematician, aren't you cool by definition? I mean, come on. And so, our moonlight rarity. It looks like it's time for a worksheet. Dun, 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 dun. Ooh, all sorts of friends showing up to join this cow. Boom. Okay, let's get to work.